career opportunities in science and engineering. So after that, we'll hear from our amazing speakers, Mr. Madhuranga Pillai and Ms. Asiri Pereira, who will break down the subject-specific details for you. Science and engineering are the heart of innovation and technology. They are everywhere. So from the phone you're using, a phone in your hand, medicine that keeps you well, keeps you alive, make people healthy, and renewable energy powering the world. These fields shape our daily lives in a way we often take for granted, but beyond the career opportunities, science and engineering gives you tools to solve world problems and make a lasting impact. Wondering, do I need to be a genius to success in this field? Absolutely not. What you need is curiosity, willingness to learn, and the drive to push through challenges. Every scientist, every engineer, or you heard, started exactly where you are now, figuring things one step at a time. Okay. So at this stage, okay, one of the biggest decision you will make now is where and how to continue your education. The good news is you have options. Some of you might go for a foundation program, other might dive straight into degree, and some of you might even be considering studying abroad. But more importantly, don't just choose a course because someone told you it's a safe or popular area. A lot of students ask me, like now we deal with lots of students over here you at UCL, so they often ask me, what jobs can I get with a science or engineering degree? Okay, the real question is, what can't you do? Okay, did you know that chemical engineers work in cosmetic industry, food production, and even in space research? And the physics graduates, they could end up in maybe a finance, gaming, and most popular one these days, AI. Nowadays, the world is evolving and now careers are being created every day. The key is to keep learning and exploring things and adapting to new things. So this session is all about this, and we are trying to give you we are trying to ease your pathways. We are trying to help you to take your decision. So to sum it up, your future in science and engineering is what you make of it. Stay curious, keep asking questions, and don't be afraid to step out of your comfort zone. Now, so I gave you the brief, and also I gave you the bigger picture. So now to give you a deeper details about the specific subjects, I'm excited to hand it over to our next speaker. First, we have Mr. Madhuranga Pillai, who's a program leader for Monash degree programs, Monash MCD programs, so a diploma, who will be talking about career opportunities in fields of engineering. And we have Ms. Asiri Pereira will take over after Mr. Madhuranga. So she will be, sharing the experience, and she will give you the exciting pathways in science. So stay tuned, and there's a lot to learn. So over to you, Madhuranga.
Thank you, Dr. Nadima. Okay, give me 1 second to share my screen. So I have prepared a small presentation. I promise it's a small one. to take you all through okay, an introduction to the world of engineering, powering innovation and connecting the world. So I'm Madhuranga Pillai. So thank you for the introduction again, Dr. Nadima. And I'm the program leader here at UCL for Monash College Diploma STEM programs, which includes Diploma of Science as Science and Engineering both. All right. Now, before we dive into the higher education opportunities in engineering and career pathways, I would like to raise the question, what is engineering? I'm not asking anyone to give an answer, but I want everyone to think, because I'm sure the audience here, at least some of you might be interested in pursuing a career in engineering. So how we define an engineer or a career in engineering is as a problem solver. If you have a background in areas such as mathematics, physics, chemistry, and if you are a problem solver, engineering is for you. If you always think differently, if you always is keen to solve a problem, then engineering is for you. So some of the skills that an engineering graduate should have. So if you are thinking of pursuing a career in engineering, so these are some of the skills that would be useful for you to have, or if you are still deciding whether I should do an engineering degree, this skill set will help you decide if you are someone who is having a design thinking mindset. What is design thinking mindset? A design thinking mindset is if you are methodical, going from a problem to a solution, because we all have wonderful solutions, but many doesn't become a reality. Why? Because we usually are not methodical. We don't follow a proper process when going from a problem to a solution. But if you have that mindset, then you can become an engineer. Then problem solving skills, technical expertise. So technical expertise is not something you need to possess. It's something you can learn. It's something you can do. Then communication skills, because a good engineer is a good communicator. Teamwork and collaboration, creativity, and innovation. If you're creative, I'm sure now you all are in schools, you all are getting involved in projects, you all are creating things, you all are developing, you all are innovating. So if you are someone like that, then engineering is for you. Adaptability and flexibility, because the engineering landscape is ever changing, it's ever evolving. So if you are able to adapt for changes very quickly, and if you are flexible for changes, then again, engineering is for you. And finally, engineering is continuous learning. So it is not something that you will stop with your degree or with your master's. Engineering is something you will learn throughout. So if you are keen on doing that, if you are a continuous learner, then engineering is for you. Now diving into some of the engineering disciplines. Now, let me tell you, these are not the only engineering disciplines that are out there. There's many, especially with the day and age that we are in 2025. Now we have many different engineering disciplines. I have just handpicked a few that are commonly discussed. Back in the day, we limited the engineering disciplines to the 5 main disciplines like civil, mechanical, electrical, chemical, and materials. But now engineering has branched out. Okay. Some of these main disciplines have combined together, and certain other areas, let's say things like computer engineering and things like AI engineering, have emerged with ever-changing needs. So if we talk about what's in demand in terms of disciplines, or what we see as teachers and as educators, students, yes, still these conventional engineering disciplines like civil, mechanical has a huge interest because they have vast amount of applications. If let's say, for an example, if you take Australia, civil engineering is most in demand. The reason being they are heavily invested in infrastructure, smart infrastructure, then geotechnical applications, and so on. And then, of course, with all these new developments in things like AI, areas such as electronics, mechatronics have become very popular as well, in order to automate things, in order to use AI. And of course, we cannot forget areas such as software engineering and so on. And like Dr. Nadima mentioned earlier, chemical engineering is one of those areas that can open up many different pathways for you. Let's say you can go into areas such as water engineering or petroleum engineering or mining, or in broader terms, process engineering. Through a degree like chemical engineering. So when we say process engineering, it could be any process. It could be a process in pharmaceuticals, it could be a process in food or beverages, or it could be a process in manufacturing chemicals. So chemical engineering is an area as such. Then we have environmental engineering, because so engineer, like I mentioned earlier, is a problem solver. So one of the main issues that we have today, even if you take the UN sustainability goals, environment issues is one key theme. So it's going to be the job of an engineer to solve those problems. So environmental engineering in terms of sustainability engineering and renewable energy engineering has become rather trending as well. And according to 2024 reports, after AI, sustainability has been the most in demand area in terms of job search as well. So that's about certain or some of the engineering disciplines that are out there. And of course, biomedical. Now, biomedical engineering is a relatively new compared to some of these other areas. But if you are someone who's keen on merging, because we have, let's say, a student who would have done mathematics and biology, because you are interested in both areas. So biomedical engineering is something you can do. Biomedical engineering is something you can pursue in order not to let go of either of your passion. So biomedical engineering is out there as well. So these are, like I said, some of the engineering disciplines you can go into. Then let me touch upon benefits of an engineering career. So what you will gain as an engineer. Of course, a good salary. We'll start there. So if you talk about the starting salaries, at least in 2024, for an entry-level engineer in Australia, they have been around 120 120,000 Australian dollars is the annual salary. So it's the starting salary, the average starting salary in 2024. Then the job security. So not just a good salary, but job security. Now, again, going back to AI, now we have this conversation, or we have this doubt. Students may have this doubt. Okay, AI is emerging. What will happen in another 5 years? I'm going to become an engineer, but in 5 years, will we need engineers? Yes, the answer is yes. Because whatever the new latest trends are, engineers are the ones who will implement them, who will come up with the solutions. So not like certain other areas where the job can be replaced by AI or job can be replaced by automation. An engineer is the one who will have to come up with the solution. So an engineering career has that job security. Then the intellectual challenge. Some of us get bored quite easily. If you are intellectually gifted, if you're not challenged, you get bored. You get bored with your work. So engineering, like I said, because it's an ever evolving, ever changing landscape, you'll always have new things to work on. Global impact, you can make an actual impact on the world. Professional mobility. Now, professional mobility is once you have an engineering degree, you're not limited to one place. Let's say you can work anywhere in the world, because anywhere in the world they will need an engineer. So you can work in Sri Lanka if you want, or Australia, or US, whatever the country you choose to, because all countries need engineers. So professional mobility will be there. And finally, the professional recognition. So I don't think I'll have to explain that. So you have the professional recognition as an engineer once you graduate, either from Monash or any other university as an engineer. And depending on the university that you graduate from, you will have the opportunity to gain professional recognition through engineering institutes like Engineers Australia and so on. So those are some of the benefits you can gain from an engineering career. Then finally, moving on to what kind of jobs. Now, I touched upon the job aspect also when I discussed engineering disciplines. But here, what I want to highlight is that because the conventional picture is when we say an engineer, it's always someone who has to go to the field, or if we say a civil engineer, is someone who wears a hard hat and let's say who wears the safety jacket and has to go to a construction site. Or when we say a mechanical engineer, someone who always have to work with engines, vehicles. No, it's not always like that. That is one part or one aspect of engineering. But if you take a pie chart of all the engineering work in the world, the majority won't be site engineers, we say, but the majority actually would be in managerial roles. Because the skill set that I mentioned that you will gain or you need to have as an engineer prepares you for that. So to become a manager. So if we some of your parents might be engineers as well, and if you look at them now, they are in managerial roles. And then of course, then you have the engineering roles such as chemical, civil. Now, when we take civil, you can further go into areas like smart infrastructure, like I mentioned earlier, as well as structural engineering and so on. So you have these different types of engineers, electrical electronics engineers, industrial automation engineers, we call them. So if when we want to automate certain processes, industrial processes, and like I mentioned earlier as well, sustainability is a big theme, a trending theme. So sustainability and environmental engineers, and test and design engineers. So test and design engineers can be from any of these areas, such as civil or mechanical. So what they do is they don't necessarily go and build. So that is not their job aspect, but they design. Because if you take the engineering, it's a process. So testing, designing are parts of this process. So you can become an engineer who specializes in that. So you don't necessarily, let's say, sometimes girls are not keen to enter engineering because sometimes they're worried I won't be able to go to a site, work with male workforce, I won't be able to, it's not safe. Uh, it's not the case anymore, but you don't have to, because you can become a test engineer, you can become a design engineer, which you can do, let's say, on a computer in an office, in a well AC office. So that option is there. Then, of course, telecommunication engineers, where you focus on infrastructure related to telecommunication, that is internet and so on, internet technologies and so on. So these are some of the jobs you can land as an engineer, but again, not limited to these. I have just picked some again, based on an Engineers Australia report from 2024 that highlights some of the more in-demand areas in terms of engineering. So those are some of the main things that I wanted to discuss in terms of engineering. I kept it very short because I just wanted to give you all a quick view of into the world of engineering. But if anyone has any further questions with regards to engineering, degrees, or career pathways, we'll be happy to answer at the end of this session. Now I will pass it on to Ms. Asuri Pereira, who is the biology expert at UCL and also the program leader for Monash University Foundation here, who will take you through the world of sciences.
Thank you, Mr. Madhuranga. Just checking, can you hear me?
Yes, I can.
All right, I will share my screen right now. Just bear with me. Okay, getting myself into slideshow mode. Can you just let me know if you can see my slide? All right, fantastic. So good evening, everyone, and thank you so much for joining us in this evening to take a little bit of your time to see what kind of options are available to you in science and engineering. So Madhuranga has provided a very enlightening view of the engineering stream, and I'm hoping to probably enlighten you with regards to the science stream. So we're going to be talking about science degrees and also what kind of career pathways are there for scientists in the making, such as yourself. So my name is Asuri Pereira, and I'm the program leader for Monash University Foundation here. I'm also a lecturer in both the Monash University Foundation here and the Monash College Diploma Program here at UCL. So I believe my area of strength is biology and applied biology. And I would like to think of myself as a science enthusiast because I do enjoy everything science related. And it's a field that really gets me excited. So firstly, I'd like to start off by kind of dispelling what people think science is. Because one of the issues I had when I was finishing off with my schooling is, I had a very limited idea about what a scientist is. So I thought that when we are doing science, we're doing biology, chemistry, and physics. Yeah, so therefore, my image of science as a school student is, someone who wears a lab coat, someone who plays around with test tubes, someone who spends a bulk of their time in the laboratory. And because of that rather limited image of what science was, I thought there was only a few career opportunities that are there for me as a scientist. I thought, okay, I'm good in science in school, so therefore maybe I ought to be a doctor, maybe I ought to be a nurse or something along those lines. So what I'm here to talk about today is looking at the different options that are available for science, right? Because it's not really the chemistry, the physics, and the biology. It's not the theoretical things that that makes you a scientist, right? And so therefore, what exactly do we mean by doing science? So a scientist is basically someone who follows something called the scientific method. Now, I'm not going to talk about the scientific method. It's basically a way of us being scientists, the code by which scientists actually work in. Yeah, so there are two streams of science. So one area of science is finding things that are unknown and contributing towards the knowledge. The stuff that you read in your textbooks, the theory, yeah, that is what we call exploratory science. You're finding things that are not yet known about a specific field, and you are adding more knowledge to that particular field. Yeah, so that is more into the exploratory field. But in addition, we also have what we call applied sciences. So applied sciences is finding solutions to the problems that we face in the world today. So I'm going to be talking about applied sciences as well in the next couple of slides to kind of give you an idea. What do I mean by finding solutions to the problems that are there in the world today? Now, some of the key things that, we value when it comes to being a scientist is, things like critical thinking, yeah, logical reasoning, yeah, finding evidence before you make a claim about something, right? And checking your data and drawing any conclusions based on the data that we have. For example, if I say that vaccines actually work and vaccines actually stop the spread of disease, I'm not just saying it because of what I feel. I'm not saying it because of what somebody told me about vaccines. I'm saying it based on what is the evidence that is there? What is the credible evidence that is out there with regards to vaccines, right? So we need to search for evidence and we need to find the research, right? So I actually tell students in my class that being a scientist or following the scientific method, these life skills are valued in any kind of profession that we do. And there's a reason why scientists are very, very versatile. You might notice there'll be scientists or people who've done a science degree who might be in marketing fields, people who've done a science degree who might be in even media fields as well. And the reason being is the versatility of it, being able to think and find answers to problems and think in a logical manner. So if you're a science student, what are the things that we value? Now, you'd be surprised, when you look at this list of things, that I do not actually say your knowledge in biology, chemistry, and physics. As a student, I actually found that even though a student might be book smart, they might know all the facts at their fingertips, right? They might not necessarily be successful in the field of science. And that is because it's not really the knowledge, but your attitude towards science that actually decides whether you're going to be successful or not. So sometimes students might feel, okay, I'm actually terrible. I don't know my biology, my chemistry, my physics. I'm not so great at it, right? I don't have the theoretical background. And yet they still actually succeed in this particular field. So for example, I've had students who've never done biology in their whole life and then continue on to do really well and even pursue degrees in that particular field. So what makes a scientist a good scientist? Number one, an actual genuine interest in what you're doing. You really, really need to have that spark to keep you going. Then, of course, I always say asking questions. I say that is the start of any scientist thinking. I have a question to ask, and therefore I'm going to come up with a solution to that question. So critical thinking. How do I look at things logically? Am I looking at the actual data, right? Is this information valid? That critical thinking, as well as taking steps to being self-aware, right? What are your weaknesses, right? And how can I improve upon those weaknesses? Because in science, to succeed as a scientist, you're going to come across a number of failures when you're doing experiments and things like that. But it's not really the failed experiments. It's how we learn from those failed experiments and how we take steps to improve, right? And do better science. And then, of course, seeking opportunities to get feedback. Feedback is really important, peer feedback as well as feedback from your teachers, right? The drive to research and learn more. I studied at Monash University, and the motto of Monash University is what we call Ancora Imparo. It's right there on the sign, the logo of Monash University. And Ancora Imparo means I am still learning. So that need to consistently keep on learning and updating what we know about something. Being organized, seeing things critically and logically and putting that information together in a cohesive manner. And one very important trait that I actually value in science students is independence. Being able to work without someone sitting behind you and telling you what to do. And this is really important because when it comes to science, right, we are not really teaching things to you sometimes. We are not actually saying, okay, learn this theory in biology, learn this theory in chemistry, right? We actually want you to learn in an independent manner at your own pace, right? And then in class, sometimes we're focusing more on the application part, right? So these are the skills that we value in science students. So moving on to what do we mean by a science degree? Now, a bachelor's program is an undergraduate degree. So if you're coming after your A-levels, you will be engaging in a bachelor's degree. So it's an undergraduate degree program. And depending on the university, some degrees are 3 years and some degrees are 4 years in terms of the duration. Now, there are some science degrees which are what we call specialized degrees, where, your degree is specializing only in one area. However, there are many science degrees of which we call general science degrees, where you get what we call the Bachelor of Science, and you can choose which kind of areas that you are going to specialize in. Yeah, so it gives a lot of flexibility, right? Because then you can choose a variety of disciplines and you can pick ones that suit you, and sometimes even more than one. And you can specialize in more than one field. And a bachelor's program is the first step to become a scientist. Yeah, if you want to be a scientist, if you want to pursue a career in science, then of course you have to start off with a bachelor's program. So that being said, what are the kind of disciplines that you find in science? Now, you can see this is a very long, non-exhaustive list over here that I'm giving you, right? And it varies from a variety of different fields. For example, you've got the medical fields, like, for example, immunology, physiology, pathology, microbiology. Yeah, those kind of things fall under the medical science fields, right? Then, of course, you've got the earth sciences, the conservation, the environmental sciences field. So for the people who are interested in stepping out, you're interested in the world around you, plants and animals and how they interact with each other, definitely it's a field that you can go into. Then, of course, for the people who like mathematics, not me, right? But for the people who do enjoy maths and the people who like those kind of sciences, there's so many other fields. For example, computational sciences, mathematics. Yeah, and then of course for the physics students, you can major in things like physics, astrophysics. For the people who like plant sciences, right? You can go into plant sciences, soil biology, and for people who enjoy chemistry, there are areas that you can major in. So you can see if you're pursuing a bachelor's degree in science, yeah, you get a bit of flexibility. You get a bit of flexibility to kind of choose the kind of areas that you want to specialize in. And in some of these degrees, for example, the Monash one, you can actually opt for even specializing in more than one field, yeah, depending on how you choose your subjects. Yeah, so for example, you can go into something like microbiology and pathology, or climate sciences and environmental sciences and conservation, right? So you have a little bit of flexibility, which means that it kind of enhances your job scope and gives you more areas in which you can apply for a job. So this is based on the Department of Labor in America, and it's focusing on what kind of areas are the fastest growing regions or the areas in science. And you might notice that some of these areas are more into application-based science and things like that. And why it's so is because of the many different challenges that we are facing globally today. Yeah, the world that we live in is unfortunately not perfect. Yeah, and there are just so many problems, and overpopulation, global warming, various kinds of diseases that are actually making, going around the earth, like pandemics and things like that. And all of these things are interconnected. So when you look at the areas in science that are currently the fastest growing, I'm not focusing on current, I'm actually focusing on the next 10 years. Yeah, what are the areas that are growing in this particular field? You might notice epidemiology is one of the more prominent fields that is growing. And this is actually because of the fact epidemiology is the study of the spread of diseases. And we just came out of a major pandemic in our lifetime, the COVID-19 pandemic. And many scientists are believing that there are more pandemics out there. And because people are traveling around a lot, diseases can cross countries very, very quickly, as we saw with COVID-19. Yeah, so epidemiology is the study of how diseases are spread, how you can manage diseases, right? And you can see that, especially after COVID-19, that field has really, really grown. Then, of course, you've got medical scientists, people, connected to a variety of diseases and things, learning how these diseases work and what kind of ways we can diagnose these diseases, how you can develop vaccines for these diseases. It's a massive area that people are looking into. Yeah, and one of the best examples is in recent history, how quickly we had COVID-19 and how fairly quickly we developed a vaccine for COVID-19. Yeah, it's actually very amazing. Yeah, in the past, it would take, decades to come for, to create a vaccine against a particular disease. And yet with COVID-19, we managed to get a vaccine in a very, very short period of time. And we managed to somehow manage this pandemic. And within a year or so, we managed to somehow or the other come back to our normal lives. Yeah, so those kind of fields. Now, food science is a field that is really, really growing. And this is because food is absolutely, it's one of our basic needs. And because it's one of our basic needs, it's, we are looking at ways of making food processors more efficient, reducing wastage in food processing. Yeah, and nowadays, how to make these processes more efficient. Then, of course, again, connected to medical things, biochemists, biophysicists, chemists, which Dr. Nadima might be able to shed some light into. We're focusing on sustainability, development of sustainable materials, all of those kind of things. You need chemists and material scientists. Then, of course, animals. Yeah, we need to know a little bit about animals for conservation, because animals are, we are facing massive extinction of lots of our animal species who are vital for our ecosystems. Right, so animal scientists are needed. And of course, animal scientists also include scientists that are involved in our agriculture industries as well. Yeah, because obviously we rely on animals for food as well. Yeah, then of course, environmental scientists and geoscientists. We are in the middle of climate change. We are facing a lot of changes to our climate change and the world around us. So we need to have people who are able to understand these kind of concepts as well. Microbiology, an area which I'm really, really interested in, because, if you look at diseases and things like that, we don't even see our enemy. Yeah, and this is where we need our microbiologists to help us. Viruses, bacteria, things that we cannot actually see, and yet kills millions of people every year. Then, of course, astronomers and physicists. And I'm sure if you're following news, people are talking about, billionaires trying to colonize Mars or trying to form colonies on the moon, right? And these are things that, it seems like science fiction right now, but it's things that people are studying. And, how can we find issues to human overpopulation and things like that? Then, of course, soil and plant sciences. Food security is a very, very important topic in today's day and age. I don't know how many of you guys are aware that the human population is growing exponentially. And at the moment, as soon as the human population reaches 10 billion people, which is not so far away, yeah, we're already at 8, right? As soon as the human population reaches 10 billion people, we need to increase our food production by 70% to feed the 10 billion people out there. And most of our food is what? Plants, rice, maize, soy. Yeah, and therefore to understand how to increase our food production is really, really essential. And it's what's going to keep the human race alive. And likewise, it's not just increasing food production, but how to make our plants resilient in the face of climate change. How can they resist high temperatures and bad weather? Yeah, and these things are really essential to feed our growing population. Yeah, so you can see how science is kind of looking for solutions to those problems, and how the fastest growing science occupations are dealing with finding solutions to the challenges that we face in the world today. So to sum it up, when it comes to finding a career in science, I would always say that there's just so many things that people can do. It's just the limited thought that is a problem. Yeah, because we limit ourselves to believing that a scientist is relegated to a laboratory. Yeah, we limit ourselves by believing that if you're going to be a scientist, you have to do a certain kind of profession. Yeah, but the reality is you really need to see where the needs are, where the gaps are, and think like a scientist and find a place for yourself. So some of these careers are based on my own experiences. working with fantastic people, my peers, my colleagues, right? Of course, one is research, exploratory science and finding application science. Yeah, of course, if you are hoping to go into research, once you have finished your undergraduate degree, you might need to consider doing postgraduate studies as well. Yeah, because research-based degrees will require you to go a little bit beyond your undergrad degree. Yeah, then of course there's teaching. Yeah, not for everybody, right? Not for everybody, but if you're someone who likes to explain things, such as myself, then that's a pathway that you can go into. Then you can join industries like pharmaceutical industries. You can join various kinds of companies that deal with production of scientific materials and things like that. Then, of course, you can go into testing laboratories, right? Whether it's diagnostic testing to diagnose diseases and things like that, or whether it's quality testing in a company, right? You can go into lab work, right? Then, of course, for people who are not really interested in lab-based work, there are various other things, like, for example, global research collaborations. Yeah. I have a friend who actually failed in his science degree, right? He was caught for something called plagiarism, right? If you ever do a science degree, you'll find it. And he actually did not get his postgraduate science degree. He got his undergrad, but he didn't get his postgrad. And yet he still has found a place for himself in the field of science. He's very skilled in languages. Yeah, he can translate languages very, very quickly. And because of that, and because of his science knowledge, he's now collaborating between multiple countries in multinational research. Yeah, he's linking European countries with Asian countries for research and collaboration in research, and, gearing various kinds of collaborative projects. Yeah. Then, of course, some of my friends, they weren't interested in working in a laboratory, and yet their science knowledge is important in sales and marketing, because all these multinational companies that deal with scientific products, scientific pharmaceutical companies, equipment-based companies, chemical companies, they need people who know the science background, but who also know how to sell products. So if you're someone who's a social person, right, and you like talking and you like, going around and meeting clients and things like that, that's a field for you, right? If you're someone who is interested in epidemiology and, health and things like that, you can go into policymaking. Yeah, join institutes that deal with researching and coming up with policies for various kinds of problems. Yeah. Then, of course, there's non-governmental organizations. For example, I have friends who are working in NGOs related to oil spill rescues and things like that. Then, of course, there's communication. Yeah, you might notice there are various scientists like Bill Nye, the science guy, or in Sri Lanka, I think there's someone called Science with Ruchira, was it? Yeah, right, who has a very active science page, right? So those are what you call science communicators. Then, of course, entertainment and the arts. I actually have scientists who enjoy drawing things and, artistic things, and they're actually using their science to educate people with art as well. Yeah. And of course, some people look at a science degree as a way to enter into medicine. Yeah, for instance, if you, do something if you do a bachelor's and you're specializing in immunology, physiology, biochemistry, microbiology, genetics, pharmacology, yeah, then of course, some students do a science degree. And then afterwards, they decide they want to go into the medical field. And then they proceed on to what we call graduate entry in medicine. Yeah, so you can see, I think, like what Dr. Nadima said, it's not what can you do with science, but what can you not do with science. The only hurdle is our limited thinking. Yeah, thinking and putting ourselves into a box and thinking, if you're doing a scientist, this is what we have to do, right? So always research, find out about the different fields, and find out how you can build within these fields and also incorporate the things that you're really, really passionate about. So that's it from my side. Thank you very much. And I believe we can now pass on to any kind of questions that students might have.
Okay, so what a great discussion we have had today. I hope these sessions have given you a clear picture of endless possibilities in science and engineering. Whether it is developing a new material, advancing, medical research, or designing smart technology. These fields are filled with opportunities to make an impact in the society. Now I know that choosing right path can feel overwhelming, but the good news is you don't have to do it alone. At UCL, we offer the Monash Pathway program designed to guide students like you toward a global recognized education. This pathway leads to Monash, Malaysia, or Monash, Australia. So where you can pursue a Bachelor of Degree in Engineering, Bachelor of Science, Bachelor of Medical Biosciences, or Bachelor of Food Science and Technologies. These are the different pathways you can choose. Through these pathways, you can start your journey here at UCL and then seamlessly transfer to Monash University. This is like a world-class education. You're going to get world-class education while you're preparing for your exciting career in engineering or sciences. So if you're still figuring out your next move after A-levels, considering this pathway as stepping stone towards an internationally respected degrees and bright future. So with that, I'd like to thank you all for joining us today, and a huge thank to my fellow speakers, Ms. Arthuri and Mr. Madhuranga, for their insightful contributions. So if you have any more questions, feel free to reach out. We are here to guide you. And of course, if you like to learn more about our Monash Pathway at UCL, don't hesitate to speak to one of our team members and scan the QR code on the flyer to join the open day happening tomorrow, actually Wednesday 19th. You'll have the chance to meet the faculty, get career guidance, and you can also observe live, lab demonstration in this lab. So we would love to help you get started on your journey. Wishing you
Okay,
all the best.
actually, before we finish, there is a student who has posed a question. The
Okay.
student has asked, can you also mention part-time jobs for someone who's considering to take graduate entry medicine after completing the Bachelor of Science while doing the MD program? So this is an interesting question because let's say a student has completed the Bachelor of Science and then they're hoping to go into graduate entry medicine. Right. First question is you need to discuss what your limits might be, right? And that is not something that I can actually answer, right? Because different students might have different capacities. Now, that being said, because there are some students, now I haven't studied medicine, but I actually get a lot of feedback from my students who've gone into medicine programs. And there are some students who actually tell me that the medicine program is very, very hectic. Yeah, it's very, very hectic. And sometimes they do have difficulty actually doing like a proper part-time kind of job when they're engaging in a medicine program because it's a very intense kind of program. And because it's so intense and because you have to cover many things that you have to keep on studying and all that, it's something that, they feel that when they're engaged in it at that moment, they sometimes have difficulties, managing their studies and a part-time job at the same time. So you need to assess your capabilities, right? And you need to see whether doing a part-time job is possible for you. Some students might actually be able to manage it better compared to others. Yeah. That being said, of course, there are holiday periods, right? And, during that time, there's no limitation to how much part-time work that you can do, right? So, some students might not work during the term, but then they work, during the holiday period, and then there's no limitations to the number of hours that you do. During the term also, there are some students who engage in it, but, they choose to engage in non-pressure kind of jobs, things that don't require huge amount of time commitment, right? And huge amount of prior preparation for that particular job, simply because, you know, otherwise they'll be spending more time on their job than actually focusing on the medical degree. So it's up to you what kind of part-time job you want to do, but you also need to also look at your abilities to manage it. And unfortunately, that you can only judge when you actually go there and based on your capability as well.
Thank you, Asiri. So, is there any more questions?
There is okay, there is a student who's asked under the Q&A. Thank you so much for asking all these questions. I like it when people ask questions. All right. So under the Q&A, someone has asked, what would be the biggest advantage of studying at UCL and transferring to Australia? Mr. Madhuranga, my mouth is a bit tired. I need a drink of water. Do you mind getting that?
Yeah. So I would say one of the biggest advantage, okay, let's say if we talk about the diploma pathway where you will do your first year, that is what we call the diploma, and you transfer to your second year at the university. You will be getting a lot more let's say contact hours, we say, with the teachers. So the learning experience is going to be much smoother, especially when you come from A levels. And the university, it's a big transition. So rather than going directly to the university, when you go through the diploma, the experience is going to be much smoother because you will have more opportunities to interact with your teachers, which might not necessarily happen at the university environment. And also another advantage is you can always go with uh, a group of friends. That's something we always highlight as well, because you have a community that you can rely on when you go, let's say, through a pathway program. And of course, the cost saving, I'm sure it's not something that I have to mention, but there will be a significant cost saving as well in terms of, let's say, doing the first year of the degree at UCL or the diploma and then transferring to the second year. I would say these are three main things, benefits of doing the first year here in your own home country and then transferring to Australia or Malaysia to do the rest of your studies.
I'd like to add to that. I think something that is not properly studied in a university setting is the number of dropout rates in the first year. You'll be surprised at the number of people who drop out of their studies in the first year in a university. From my experience as well from at Monash, you know, I knew personally at least about 3 people who dropped out in the first semester of their studies, and another 2 people who dropped out by the end of the second semester of their first year. So from my circle itself, and that is just a small circle, right? From my circle of friends itself, 5 people dropped out in the first year before they actually went into the second year. And that is something that is an advantage when you are actually in a smaller setting, because when you're in that impersonal kind of setting in a situation where there's, you know, hundreds and thousands of people, sometimes, you know, sometimes batches are 500, 600 people, right? Sometimes you lack that contact, especially we're coming from smaller settings here in Sri Lanka. So that transition is a very difficult transition, and not every student actually succeeds in that first year, you know, jumping straight from school into that. So, you know, that 1 year has been, I think if you look at some of our students who went into their degree programs, they did the first year with us and then they went on to the second year in Australia and Malaysia. One of the main things that they actually say is because they're going with people that they know, they feel a little bit more comfortable and their adjustment is actually a little bit more seamless because they're not isolated, they're not by themselves. So that is actually something that is interesting to note. Okay, we've got 4 more questions. Yeah, we've got 4 more questions. I think we'll answer those 4 questions, and then anything else we might need to address maybe via email, right? If there is, we can take down the questions. So one of the questions is asking, can I know what are the minimum qualifications to apply for astrophysics? I believe it is actually the same qualifications as a Bachelor of Science, right, Mr. Madhuranga?
Yes, that's correct. As long as you have done A levels physics for A levels, and as long as you have successfully completed physics at A levels, you can apply for the Diploma of Science, which will gain you access to Bachelor of Science, and under that you can do astrophysics as one of the majors.
Okay, so it's the same requirement. So I hope that answers your question. We've got one more question. Very interesting, unique question. Can we combine graphic design, photography, and fashion design with engineering? I would
Okay.
say yes. Material
Yes, of
sciences,
course.
yes,
Yeah.
absolutely. Right, yeah.
So what I'll do is I'll give you some examples where we can combine these different areas in engineering. So let's say if you take things like graphic designing and engineering, yes, areas such as virtual reality, augmented reality will actually require you to have that background as well on top of your engineering background, as well as we have this area called CAD, that is computer aided design. That is where you use softwares to do structures. Let's say it could be mechanical structures or it could be infrastructure. So in order to do this, you need, or you can, or you should have a designing background as well. So if you already have a graphic designing background and with an engineering degree, you can do wonderful things. If you take photography, okay, photography and engineering, where these two things to come together. Drones. So if you want to work on a technology such as drones or optical engineering, we say, where you work on camera technologies. So having that photography eye, we say, would definitely be sure. And fashion designing with engineering. Yes, like Asir mentioned, material development for wearable technology. Your smartwatch is not a smartwatch, but your smartwatch. Because back in the day, a smartwatch nobody wanted to wear because it didn't look nice, but now everyone wants to because it's fashionable. So a fashion designing aspect is there in engineering as well. You can combine two together. So yes, the answer is yes, you can combine these different areas with engineering. And these are some of the examples. I'm sure we can find
Yeah, and like I
many
mentioned, I
others
think
as well.
sustainable
Yeah.
clothing is quite very
Yeah.
well, whatever, making clothing sustainable, reducing wastage. Yeah, all of these things are really, really important things because, I mean, let's face it, we need clothes, right? Yeah, yeah, and that's a basic need for humans as well. And that being said, clothes are very wasteful. The materials that we wear are very wasteful and harmful for the environment as well. So sustainability in fabrics is something that people are looking at as well. Next question, second to last question. Are there any jobs for a graduate in biomedical sciences in Australia, or do we need to pursue a master's in a certain area to land a job? So my answer to that is it depends on what kind of job you want. Now, if you are doing immediately after undergraduate, then of course you might not be able to land research jobs. You might not be able to join into a pharmaceutical company to do research, right? So for an undergraduate, most of the jobs in biomedical sciences will most likely be working in a lab, testing lab, testing for materials, testing for diseases, diagnosing, those kind of things, right? Because those are the ones that require a slightly more basic skill level, right? And those kind of things are what you might get for an undergraduate degree, right? So if you want to do research in biomedical sciences, then of course you need to do a master's program. Yeah, and of course you need to do master's or PhD, right? And with Monash degree, sometimes if you have got like a first class and a second upper in your science degree, then of course you might be able to even go directly into a PhD without doing the master's program. So you can find ways to pursue that, but that's mainly if you're interested in research, finding new things and, coming up with solutions. But if you're going as an undergrad, then of course you can consider things like testing laboratories, those kind of laboratories, doing more of the technical stuff, working as a technical kind of officer. Yeah, so it really depends on what you want to do as a scientist. And the final question, I believe, is, Yeah, the final question is, I want to know the advantage of studying in Malaysia. Is it 100% confirmed if I join UCL? Okay, I think Malaysia is my area because I actually studied in Malaysia. So some of the advantages of studying in Malaysia is the proximity it is to Sri Lanka. I found it is a very comforting thought to be able to get on a flight and get home in case there's any kind of emergency. Yeah, like most of my friends in Australia, um, very rarely because come back home because they during their break time, sometimes they need to work part-time to make, to cover their living expenses and things like that. So very rarely do they get that opportunity to come home frequently. But in Malaysia, I had that luxury of coming home um, as often as I want. So if you're someone who would like to have the benefit of coming, traveling in a convenient distance, that's one of the benefits. Another benefit of studying in Malaysia is, of course, the cost. Yeah, both the studies as well as the living expenses is significantly less compared to studying in Australia, right? So there's a cost factor involved, and of course it's much easier like that. And another benefit that I found in Monash, Malaysia is with regards to some of the areas that they offer. For example, if you are studying, let's say, medicine, right? Or if you are studying biomedical sciences or even environmental sciences, yeah, they actually have a strong regional focus. Yeah, more than going into a country and getting a degree in an area and then specializing in things that can't be applied to Sri Lanka, right? Monash, Malaysia is actually an Asian country. Yeah, same temperature, same climatic zone, same conditions, similar kind of genotypes when it comes to the people that live there. So therefore, if you're doing biomedical, if you're doing medicine related things, yeah, you might find that some of the research is applicable to Sri Lanka. So including the environment, same climatic zone as well. So in these kind of situations, I feel that Malaysia has a lot of benefits, especially if you're somebody who wants to help in the development of your own country, right? I think those are some things that you can consider one of the other advantages in Malaysia. Okay, we'll go through the last two questions. Lochana had one question with regards to a specific age to apply for Bachelor of Science. Mr. Madhuranga, is there a specific age limit?
To apply for Diploma of Science or over there?
Bachelor of Science.
Directly. They have to be 17, if I'm not mistaken.
17,
if they're going
minimum
directly.
age is 17, I think, and you have to have
And that's
completed
with
your
Guardian,
years,
yeah.
yeah. Okay, with regards to, is it 100% confirmed if I join UCL? What does that mean?
I assume that he or she is
The student
thinking
can
if they do the
transfer.
diploma, yeah. So yes, it's a guaranteed entry. So once you complete your requirements in the diploma, either for Bachelor of Engineering or Science in Monash, Malaysia also, the second year entry is a guaranteed entry.
Okay, I think we have to go through the last two questions. Mr. Madhuranga, have you answered that question? Can I do this program even if I'm average or just above average student?
Dr. Nadima will answer it in her closing remarks. I will just touch upon the practicals and physics experiments. I was actually typing an answer. So yes, we do have the lab facilities. So I'm actually sitting in the engineering lab. So if you come to UCL tomorrow, we can give you a lab tour as well as show some of the experiments that we are running. So you can experience engineering physics as well as all our other science areas here at UCL. So you can see our 3D printers and some of the student projects also that they have done in the background. Yeah, so that's about the labs.
And I think the last question I think we can accommodate is a Bachelor of Mechanical Engineering in the automotive field on offer? If so, what awaits successful graduates from this field?
Which question is that? I think I've lost it.
No, it has been
Can you
sent
repeat
as a
the
direct
question?
message.
Okay, could you please repeat the question, Asiri?
Is a bachelor's in mechanical, sorry, in mechanical engineering in the automotive field on offer? is the bachelor's in the mechanical engineering in the automotive field on offer? If so, what awaits successful graduates in this field?
Okay. So at Monash, the mechanical engineering major is available. But if you're looking at a specific major or a specialization in automotive or automobile engineering, which is unfortunately not. However, in mechatronics engineering, you have a branch called automation, which is available. So in mechatronics, you have two areas you can go into. One is robotics and the other one is automation. So automation is a specialization that is available through the mechatronics major, not the mechanical major, but the mechatronics major. So I hope that answers your first part of the question. Then the second part of the question, actually, the answer is there itself. So if you graduate as a mechatronics engineer with an automation specialization, you can get into areas such as industrial automation. So that gives you the broader idea. So it can be any industrial process or a production process which needs to be automated. Now people want more and more things to be automated. So having that background will take you there. But if you are focusing on the automobile aspect of it, a mechanical engineering degree would take you there, where you will be able to work on things such as, let's say, now Formula One is very famous. I'm sure if it is someone who is interested in that area. So that is something that you can go into. So designing vehicles, designing cars, designing EV, electrical vehicles, which is another trending area. So these are different areas that you can go into from a mechanical aspect. So yeah, so both let's say areas of opportunities are there.
Okay, so one student had asked, can I bring friends tomorrow? I said yes. Right. Okay, so I think
do let us know. Sorry, Asmi. So do register using the QR code if anyone is planning to join tomorrow. So we have an idea of who's coming and what we can offer. Okay, so looking forward to seeing many of you tomorrow as well.
Okay, so Nadima,
Okay, so
there's one question I think for Dr. Nadima to answer, the one about support. Yeah.
Okay, so the question I got is, can I do this program even if I'm average or just above average student? Will teachers teach and support me? Well, my English is fine. Yes, of course, you can definitely do this program. So as I mentioned in my introduction, so all the great sciences, they started at one point, like, they were students like you guys, right? So being average doesn't mean that you can't do anything. You don't have to be a genius. Being average is, or just above average doesn't mean you can't success. So you can actually. What matter most is your willingness to learn and also your effort, to be honest, your effort. Curiosity and your hard work. So will pay off eventually. The teachers will support and they will actually, UCL is a good place to study, to be honest. So we have a support system and teachers will always support you and guide you. So especially if you ask questions and stay engaged, so teachers will support you. You mentioned, so your English is fine, so you won't have any trouble understanding a lesson. So just stay committed and you will be great. So, so answering to that question, I think we have to now finish this session. So I would like to thank you all. I would like to again thank Ms. Asiri and Mr. Madhuranga and all of you for joining and wishing you all the best in the future studies and careers. And thank you. Have a great evening.